This God is good though. Yes, now. It's time to give him praise for everything he has done for us. For daily protection and for the gift of life. Hallelujah.
At this point, we have to clamp the meter rule to the desk or table at the distance 10 centimeter or whatever is going to be given during the examination. And then we'll also clamp another meter rule which we will use to measure the distance from the ground to the pin, the optical pin pointer. As you can see, the optical pin is attached to the meter rule using the plasticine. That's what we did. The needle is like a pointer. At this point, we're slipping in a hanger through the horizontally placed meter rule so that we can hang our masses. We actually use a metallic lightweight string to do that. Meanwhile, we're setting up our data collection where we're going to take our readings. So we drew a table which will give us the length at which the meter rule is being clamped to the table, and then also the distance of the optical pin where it pointed at the vertical meter rule while there was no weight or no mass attached. So we're also going to record the position of the optical pin when the hanger is at 50 gram mass. After taking the reading for the first mass, we took another reading for the second 50 gram mass. We took where the pin pointed at, which was around 10 centimeters. So we recorded that down. Now we're slipping through the third mass of 50 gram and checking the distance. We're seeing something around 11.2 centimeter.
No, it's 3. Okay. 11.2, yes, sir. 2.
We slipped in the fourth 50 gram mass
12.
through the hanger, and also we took the reading at that point. I'm seeing something looking like 12 centimeters on the vertical meter rule, and then we're about to slip in the last 50 gram mass. As you can see, we had to make do with the other masses we had, and sum them up to 50 grams. No?
13.10.
No, 30.2. That's 2.
Okay. Then now, we have done it. That's one thing. Then offloading.
It's a different.
When you're not offloading it, that is going up again.
Okay.
So we're offloading and we now have from the bottom we see have like 13.20. Then now we remove 50.
So remove the first one. So this time we had to try another set of readings, which is offloading each mass from the hanger. So we did that and we started to take the reading, and we took it the length on the vertical meter rule as x2.
11.4.
11.40.
At this point, we're going to repeat the same experiment from top to bottom, but we're going to do it in a beaker of water. We're going to take the masses submerged in a beaker of water.
This is what we're reading. What's the Bible? Don't everyone to go. You can read it. Stay here and read it direct. You are reading what God.
Please take note at this point that when you're taking your readings for the pins at the vertical meter rule, you have to be careful to avoid parallax error. Try as much as possible to look straight between the pin and the meter rule so that we do not make errors of parallax.
0, which is 9.30. S 0 is equal to 9.30. Then now 50. First one, 50.
Nine point nine. 9.9.
Okay.
Ten point six. 10.6.
No, you are reading it better. I mean, there were some
That was now when you do
errors.
it, yes. Then we can repeat it. It's 150 now.
11.2. 12.2. No, 12.
Yes, for 200.
12.00 back.
Yes.
Okay, this is 250.
No, 12.3. 12.3.
Yes.
Then when we start offloading, we still have it as 12.30.
Offloading. Offload. Okay, because we're not doing water now. Air first at 20 length, 20 for the meter row. Now we also repeated the same experiment for the horizontal meter row clamped at different lengths. For example, we clamped it at 20 centimeters. The first experiment was clamped at 10 centimeters. So this second experiment we're going to try at 20 centimeters. So we tried all the different points, waiting for our exams on Monday.
9.4.
They don't need this one. They don't need
9.40.
They don't need offloading, taking it
Yes.
off. Why would they may give us this one? If you answer this and this, you equate it. You answer to find the difference. So now this one now you will now say, what did we get as when it is water? 8 point what?
9 points.
Can't be 9. It was when it's in water. What is this? And this one is 8.9. Do you understand?
Yes.
So now they may give us this one for multiplication. Find D, which is now give us 9.3 minus 8.9. Minus 8.9. It was 0.4. 0.4. So now the second one needs to know 9.9 minus 8.9.
1.
And now
1.00.
So 10.5 minus 8.9.
1.60.
1.60.
1.60.
Okay. Then 11.3 minus 8.9. 2.4. Then they will give us 12.4 minus 8.9.
3.5.
3.50. So it finished. They asked us to plot a graph of this against this. You understand? So then now when it finishes, then the lesson starts start putting finished. They won't go beyond this. They may also ask us to add this. Listen. They may ask us to listen to what I'm saying. They may also ask us to add this together to this, which you now in that case you will now add some of this nature. Serial number, masses, but put the gram or put in grams. Then x1 is centimeter, x2 is centimeter, x is centimeter, and then d is equals to x minus x0
Plus.
x minus x0. I am putting x0. It's not when they work on it, you put x, they say it's wrong. They may decide giving whatever thing they like. Do you understand what I'm saying? They will give anything they like. I'm putting this one here. So now, when you are not doing this now, what you do for this now is this. Then this is 50, 0, 0, 100, 0, 150, 0, 200, 0, then 250, 0, 0. Is that right? So now, this plus this divided by 2, which gives us 9.3.
Looking for the average.
9.5. Which like you see x1 plus x2 over 2. I want to see. Evaluate this. Is that right? Evaluate this. So 9.50.
That's 21.
50.
Still 10.50. Same.
11.30. 11.30. Then now this is
12.40.
12.40. So the difference here now. So this one is still maintain this particular. Then 9.35 minus 8.90. That's what to give you D now. I see what you are doing here now.
Yes. It's the
Give us
average.
What's the average? Add this and this.
0.45.
Are you sure?
Yes.
0.45. Then 9.90 minus
It's 1.
is 1, okay? 1.00. This is correct, but
Yes, 1.60 and so on. Yeah, correct.
2.40 and 3.50. So they ask us to plot a graph of this against this and this against this. They ask kind of a thing. Or they ask us to plot a graph of this and this. Or they ask us to plot any type of graph. Sometimes you may plot the graph of this one, the air, and that of water. So you see without the depression. Am I communicating? Yes. Also, somebody's nature. If this, let's say this is the mass, and this is the length. Is that right? And this is. So if this is 50, 50. So you may see a graph. If it comes like this, because they may ask you to plot a graph of this against it. That's why I do this one against this, or this one against this. We say plot graph of this against this, so which means mass here, then this one. We say plot this one against it, then this one will be distance here.
Yes.
Am I communicating?
Yes.
You don't go ahead at this, it's the mass practical. Is that right? Okay. They may give us a measure. So it'll be 15 centimeter, 10 centimeter, 30 centimeter. You know, 30 centimeter, that's the problem. That's why you should buy like A4 or drawing board or drawing paper. Is that right? So let's say this one, this is 15 centimeter, or this 20 centimeter. 0 to this is 18. Okay, let's say 18 centimeter. Replace it with this. This is 18 centimeter. Right? You draw 18 centimeter. Check where's 9 here. Where's 9? Yeah.
Yes.
Yes.
9.
Wait, move your head.
Move your shadow.
Okay. So which means from here to here is 18. And from here to here is 9. So which means you can place on this nature.
Dotted one.
Yes. So that's it. Do you understand? Which is from here to here is 18 centimeter. Then now, from here now, it tells me to do the same thing. From here. This is 9 centimeter. So here to here is also 9 centimeter. Do you understand what I'm saying? So now, they now ask us, take a profile of the mirror. Now draw a mirror like this. And measure 3 centimeter. So from here, measure 3 centimeter. And they say 3 centimeter. And here.
Up small.
Up small. Yes.
Okay.
Then
I don't understand.
Yes.
no.
It's okay.
It's okay.
Yes,
It's
that's
okay.
okay. Good.
Is there a
It's
bank?
okay. Yes.
So we have to work. It's 3. So you now see that from here now, here is 3 centimeter. Am I communicating? So now, they may not ask us again. Take an angle. Take an angle. They may ask us to take an angle, or they may ask us to draw a line. 2 things. Take an angle or draw a line. So if they say take an angle, maybe
Most
say
likely say
20.
draw a line.
Yes, they say 20 degree. So you bring a protractor.
Protractor.
You draw a line.
Measure 20.
You measure 20. And you see this is 90. Then from
Count
here to
20.
10, 20. When they say 30, measure here. 40, just like that. Am I communicating? So 30. Then measure this way. Then take a rule now. Join it.
I think that's the incident.
Yes. So, let's do something. Yes. So now here is
20 degrees.
20 degree. So they may also ask us, listen to me, they may also ask us to make up 90. Yeah, normal. So you take this one now. Let's say normal. If they ask you, they need ask, go ahead and do this. This is very 90. They take this, join it straight. Yeah, put this one. Yeah. That's one. Yes. Yeah, put it on. Is it here? It's not. It's here. I need it. Look at it here. And
Correct. Yes. Now join it.
this one.
Yes. Yes.
And this
Correct,
one,
yes,
Yes,
correct.
okay? And this is not the
This particular experiment, there are always so many errors.
lot of errors.
So many
So
errors
now you
due
have
to
done this
measurements.
one. So from here to here, automatically here is also
20.
20
Alternate angle.
alternate angle are equal. Is that right? So now you now place a pin here.
There's our optical pin.
This is a pin.
Any 2 points. They won't tell you where to place. They just tell you
Place
any
any
two
2 points.
any 2 points on the incident line.
The middle. What is the middle is what you're now putting to us. I'm not communicating. Come and stand here. You can stand here. Shift back, shift back, shift back. Shift back. Then now, watch. You see the line. If along the line inside is straight, you will know. And if it's not straight, you will know. So now,
is there?
can you see now?
Yes,
Sorry, sir.
Yeah, I place it. Again, I think it's here. I place it. Then you take this one again. Because you are no longer seeing the one inside. You only see this one.
So,
Okay? Ought to be equal from here to here. Because the law states that the angle of incidence is equal to angle of reflection. That's the law. They must be
they should be
equal. So now, if we measure this one here, from here to here now, it gave us 1.5. It gave us 1.5. The distance says 1.5. So which means ideally is not correct. It did not view well.
there were errors.
That's an error.
That means there's error.
It did not view well. But nevertheless, since it's practical, what you do is you measure. Now let's measure this one. Now look at what we did now. Now we did it to be 20. From here to here now, we even made mistake. This one says not even 20. Look at 20 here. I get what I'm saying now. So now, from here now, maybe now from this one constructed, I made the mistake. From here now, this is 10, 20, 22. I get now. So this is now 22 degree. Alright?
So it's almost correct.
It's almost correct. So now you measure this angle. Measure this angle. So you measure this. From here to here is 10. This is 19. So here is 19 degree. So here is 1.5. As an experiment, they indicate arrow here. Am I communicating?
Yes.
So now, they may ask us, they may give us this angle. Maybe they can give us here to be theta. Give you also to be theta. They may ask us to add this and this. So you will now see that it is still a figure. They will not give us the same number. I theta 1, theta 2. Am I complicating? Then theta 1 plus theta 2. Then theta. So Tita 1 plus Tita 1 give us Tita. Are you going to follow? So now, if you now like the experiment we did now, this is what 20 degrees. Then now, when you measure this one Tita 1, they will call this one Tita 1 too. Huh? They will not give it, they will call it Tita 1. So if you this is also Tita 20 degrees, which is this one. Am I complicated? Then Tita 2, 19 degrees. They would not, this plus this divide by 2, 19.5.
0.355.
Am I complicating? So you done that one. You done the first one. Then they ask us the second one. They may give us this one. Sorry. They may give us this one, sir. The centimeter, the length here, to the 3. And they may give us here. The length.
Yes.
To the 3. They may start from 1 or they may start from 5. They don't say it must be 3. I will talk to you.
Yes.
It doesn't must be 3. I'm not saying it must be 3. So now,
They start
they have
from
done
any
this one.
number.
This one. They may say 2. They may give us this one to be 4. Am I communicating?
Yes, sir.
Give it to be 4. Then they may ask us, they may see ask us for this. They may see ask us to maintain the angle. Or they may give a different angle. When they say 4 centimeters, 4, when they put it, don't put here, 4.00. So you will do this, you get this, you get this, and get this. Am I communicating?
Yes, sir.
The same process. I think you can do it now.
Yes, sir.
Can we?
Set me free, oh God, where will I be? Oh, carry me in your hands, oh God, carry me. Carry me in your hands, oh God, carry me. Yeah, carry me, carry me, oh God. Carry me, Savior. Carry me, oh God. Where will I be if not for you? Carry me. Jesus, I give you praise. Carry me, oh God. Carry me, oh God. Ese chukwu kike na regulate. Carry me. Hallelujah. Carry me, oh. Chukwu we give you praise. We bless your holy name. Carry me. Jesus, it's all about your grace. It's all about your love. It's all about you, oh God. No one can change my story. No one can love me like the way you love me, oh God. No one can love me like the way you picked me up from the miry clay. You set my feet upon the rock to stand. Oh, I love you, Lord. I give you praise.